Hello class, welcome to the final segment in the week 6 material, and in this final segment we're going to take a look at something called a casting function, which is basically a function that allows us to convert from one data type to another. And the main casting functions that we can work with are what's shown up on the screen here. So here I have simple variable x, which I've set equal to 50. And then here on line 6, I have this variable called as string equal to this bit here on the right-hand side. And this right here, this str, that is in fact a casting function that takes the value in the parentheses here and converts it into a string. That is, it's telling the computer to look at this value in the parentheses as if it were a textual item, as if it contained a text or just something that's not standard numerical value. So that's what's going on line 6 here. str takes the variable x and essentially just converts it into a string. That is something that is treated as a textual item. And then similarly on line 7, here we're using this int casting function. And again, we take the variable or the value that's in the parentheses here, and we convert that into an integer if at all possible. So this is something that we've kind of already alluded to when we talked about the input function way back in week 2, how if we want the user to type in a numerical value, we had to use the int. And turns out we're actually explaining what's going on here when we talk about casting functions. So this input function, the result we get back from that is whatever the user types into the console. Then once we have that result, we attempt to convert that into an integer that is a numerical value, and that's where this integer casting function enters the story. So we've kind of already seen this in operation. It's just not something that we've stated directly, but the value that we encase in the parentheses here, the computer will attempt to convert that into an integer. And then another casting function is the float function, which sort of does the same thing that we do on line 7, except instead of converting something to an integer, we're taking the value in the parentheses here and converting it into a floating point number, which is a fancy way of saying a number that is not an integer. That is, it has decimal places. So int of some number or int of something attempts to convert it into an integer. Float of something attempts to convert it into a number with decimal points or decimal places. I mix those two words up into one word. Or another way of saying that is a floating point number. That's a technical term for a number that has decimal places. I almost said places again. And then another casting function, which is a Boolean casting function, and that's given by this sequence of characters, which is usually read off as bool. And then whatever number you put in the parentheses here, it will convert that into a Boolean. And basically the way that this works is if you put a 0 in the parentheses, you get a value of false back. Again, a Boolean is either a true or a false. If you put a value of 0 in the parentheses here, you get a value of false. And if you put anything that's not 0 in the parentheses here, you get a value of true. And if we want to verify that this is in fact working, we can try and print that information out. So here I'll say print as string. And you can see it looks like it just prints out the same old value of x. Now, if this is actually a string, then I should be able to concatenate these two things together. So to sort of compare and contrast this, I'll also say take the original value of x that we started with here on line 4 and add those two things together, which should just be a standard 50 plus 50, which is 100. But if I convert that information to a string, then I should get a concatenation being performed here. So if x then gets treated as a string, which will be converted into a textual item as a textual item that is just a 5 and a 0, then we would get a 5 and a 0 on the left-hand side, a 5 and a 0 on the right-hand side, and you would join those two strings together to get 5050. And if we run the program now, we can see we do in fact get a standard numerical addition here. But for this print statement, we get a concatenation, and the reason why is because we took what x was originally and told the computer to treat that as a textual item. That is, tell it to treat it as a string. Now, if we want to see these come into operation, we're going to have to change some things around here. So I'm actually going to disable this on line 9 to avoid an error message. So now I'll say x equals 50 in quotation marks. And I'll also disable this on line 6 because it's inconsequential. So now we have a string here that is something that's being treated as a textual item. But if we run what's on line 7 here, we can take that textual item, again in this variable x, and convert it or tell the computer to treat it as a number. So we essentially take what's in the variable x, that is what's in the parentheses here. We tell the computer to convert that into an integer, which is a number, and that result then goes in this variable on the left-hand side here on line 7. And then here we almost do the same thing on line 8, except here, instead of converting it into an integer, we're converting it into a floating point number, which is also a numerical value, but as we'll see, there's actually a bit of a difference between doing int and doing float. But if we want to see what the value of, let's say, as integer plus as integer is, and again, compare that with what we would get from the original value of x. So just like before, this will do a concatenation since x is a string defined here on line 4. But if these are in fact numerical, if as integer is in fact holding on to a numerical value, then that should do just standard mathematical addition here. And you can see we do in fact get a concatenation from what's on line 11 and what's on line 12. We get a nice mathematical addition. And this should also work if I use the floating point conversion instead of the integer conversion. And you can see there's a bit of a difference appearing in the console here. So I still get the same result that I had before. And it looks like I get the same number that I had before, which I do, but you'll see I have this 0.0 here because, again, that's being treated as a number with decimals, whereas this is an integer, meaning no decimals whatsoever. And there's actually a pretty big difference between doing line 7 and line 8, especially if your string looks like it's holding on to a number that has decimals in it. So here I have a string that is read as 50.25. Again, that looks like a number with decimals in it. And it turns out, I'll actually focus on what happens if I try to apply the int casting function, that is what's on line 7 here. If I try and apply the int casting function to this would be the result that I get. Invalid literal for int with base 10, 50.25. So, if your string here has a decimal in it, you can't use the int function to convert it into a number. In fact, if you really want to be on the safe side, anytime you have a string that also is holding on to your number, use the float function over the int function. The reason why you would want to use an integer instead is primarily in the name of efficiency. So if you're doing math between integers, it's actually a much easier and more efficient process for the computer. The computer needs less memory and less processing power to do math with regular integers. For floating point numbers, it needs more memory and more processing power. But with how powerful computers are nowadays, it's really hard to find any noticeable difference between using an integer over using a floating point number. So if you really want to be on the safe side, just use the float function to convert any string that also has a number in it you take that string and convert it into a number. The best way to maybe do that to avoid the possibility of an error message would be to use the float function. So now you might be wondering, why would we need to use the float function? Why can't we just take this and convert it into a number? But as we'll see when we talk about the week 7 unit, when you read information in from a file, everything that you read in from that file will be treated by default as being a string. So even if you read in a spreadsheet that has a whole bunch of numbers in it, every single entry in the spreadsheet is still going to be treated as a string. So in order to get the computer to treat that as a number, then you have to utilize some of the casting functions that we demonstrated here on line 7 and 8 to tell the computer, I want that numerical entry to be treated as a numerical entry instead of having the computer treat a numerical entry as just regular text, i.e. just like you would a regular word, like the word hello. But that's going to do it for this segment on casting functions. And with that, that's going to do it for the week 6 unit. So with that, I will see you all in the next weekly unit where we'll primarily talk about files, working with external files, as well as some other useful tidbits of information. So I will see you all there.